Why are elements used differently based on their properties? Imagine a world where every material behaved the same way. It would be chaotic and hard to build anything. The reason elements are used differently comes down to their unique properties. Each element is made of atoms with a specific number of protons in their nucleus, called the atomic number. This number not only tells us what the element is but also influences how it acts. The way atoms are built affects how they interact with other atoms. Electrons, the tiny negatively charged particles orbiting the nucleus, are key players here. Their arrangement in shells around the nucleus determines whether an element is a metal, nonmetal, or something in between. Metals, like copper and iron, tend to give up electrons easily, making them good conductors of electricity and heat. Nonmetals, such as oxygen and nitrogen, usually gain electrons, which helps them from compounds like water or salt. Chemical properties are about how elements react with other substances. Oxygen, for example, is very reactive and supports burning, which is why we need it to breathe and why fires need oxygen to keep burning. Noble gases like neon and argon are very stable and do not react much at all. That's why they are used in lighting and in creating inert atmospheres in laboratories. Physical properties like melting point density and whether an element is a solid, liquid, or gas at room temperature also matter. Aluminum is lightweight, so it is used in airplanes, while gold resists tarnishing, making it perfect for jewelry. The periodic table helps us understand these differences. Moving from left to right across the table, elements tend to become less metallic and more likely to gain electrons. Moving down a group or column, elements usually become more reactive and have different physical traits. This layout helps scientists and engineers pick the right element for specific tasks, whether it's building bridges, making batteries, or creating medicines. Some elements can exist in different forms called allotropes. Carbon is a good example. In one form called diamond, it is extremely hard. In another, called graphite, it is soft and slippery. Both are pure carbon, but their atoms are arranged differently, leading to very different uses. Diamonds are used in cutting tools and jewelry, while graphite is used in pencils and lubricants. We use elements differently because each has a set of traits that make it suitable for certain jobs. These traits come from the structure of their atoms, especially the number of protons and electrons, and how they are arranged. Understanding these differences helps us make smarter choices in technology, health, and everyday life. It's fascinating to see how tiny particles can have such a big impact on the world around us. When we learn why elements behave the way they do, we get a clearer picture of how the universe works and how we can use that knowledge to improve our lives.